is 7.4, which is the very last skill that we need in AMath for this chapter. Okay? Now, so in 7.4, we are interested to look for the area of, okay, the old title for this topic is called rectilinear figure. Okay? But it's just a fancy name for polygons. Okay? It's just a fancy name for polygons. Means that the edges are all straight lines. Okay? And then you have different points on the thing. Okay, so currently, I think the easiest thing to look at is area of triangle. Okay? And most of the time, for AMath, we'll look up to quadrilateral. Sometimes pentagon, but I think for most of the time, we'll be looking at this or triangle. Okay? So, let's say now this thing is being placed on a Cartesian plane. How are we going to find the area, okay, of this thing? Alright, so the traditional way is to look for your different lengths, and you need to do a little bit of trigo to find this angle, that angle, find some formula here and there. Now, but the nice thing about using this in a coordinate plane is next time when you want to map out something on a Cartesian plane, you can assign the coordinates on your own, and based on these coordinates, you can find the area of your piece of land, something like that. Okay? So how are we going to do this? Okay, the idea is, let's say if you have this coordinate, let's say if you want to start at one point, I call this A. Now, then I need to go to the other side, B, C, and D. Okay? Now the letters, not so important, but the coordinate, the sequence itself, very important. So let's say if I start with this one, right? I will need to go to the next point in the anti-clockwise direction. So my x2 and y2 must be over here. Okay, so this is the rule of the game. Okay, the next point, the next anti-clockwise point, which is over here, x3 and y3. Oh yeah, I'll explain later. Okay, and the next anti-clockwise point is x4 and y4 over here. Okay, so now how to find the area of this thing? Now, so the formula is the area of this quadrilateral or whichever shape in general would be half times whatever that is. So half, okay, and we're going to start off with this point first. We have our x1 and y1. And then I have x2 and y2. Okay, I'll list down x3 and y3. Okay, and then I'll go on forever and ever until I reach my last point. Okay, so xn and yn. Let's say if I have more than 4 points. Okay, I need to go on forever and ever. But now since I have 4 points, right? Okay, let me stop at these 4 points. Now, do we end here? No, we have to close the loop. We have to write one more point over here, back to the original x1 and y1. So we need to write out this thing to prepare first. Alright? And how do we find the area? It is to do a series of addition and subtraction and multiplication. So we will need to take x1 times y2 plus x2 times y3 plus x3 times y4 plus these two things multiplied together. Okay? And we need to minus this thing. We need to minus this one. We also need to minus this one. And we also need to minus the last one. Alright? So the blue color one from top down, we add. The red color one, we minus the products. Okay? So this thing looks like shoelace. So we call this the shoelace method of finding an area. Okay? Now, how are we going to look? Are we going to apply? Okay, so what is the reason? Why on earth did this formula come about? Okay? The proof is actually, the idea behind the proof is actually, because you have a big fat thing over here, what we are going to do is we're going to look at a bigger, fatter thing, which is the bigger rectangle surrounding this one over here. Okay? So the idea behind the proof is that you take the big rectangle, right? You minus off the small triangle above. You minus this one, you minus this one, you minus this one, you minus this one. Okay? Then is equals to the area. Okay? And in the process of doing all this fancy junk, the summary is in a very neat form over here using this formula. Okay? One more time. So where on earth did this formula come from? Using a bigger rectangle from the area of the big rectangle minus off the other 4 triangles. Okay? In order to find the area. So the very neat way to express this is through the shoelace method over here. Okay? And with this one, right, let's take a look at question 1. Okay, let's take a look at question 1. And let's see how do we apply this method when we want to calculate the area of a triangle. Okay? So over here. Okay. Now, so how do we find the area of this triangle? Okay. It's just a 2-step thing or a okay, maybe at most 3 steps. But very easy one. Trust me, very easy. Now, the first thing that we'll need to do is we need to pick a reference point. So which point do you want to start first? A, B, or C? It can be anything. So which one do you want to start first? A. So what is the coordinate of A? So we need to go at A, 5 and 12. And then we go anti-clockwise. The anti-clockwise direction is rather important. Anti-clockwise, the next point is B, -2 and 3. Okay? Then the next anti-clockwise point, your C, 7 and 6. Okay? And look back to the original point, what is that? 5 and 12. So we must end at the original point over here. Okay? Now, next one, we need to do a series of multiplication for this one. And then we need to minus off those things over there. Okay? So let us take a look at this one. So this is half. Now I'm going to keep this over here. Okay, so this one is actually the modular sign. But I'll tell you what it works later. Okay, so first one, let's take a look at the blue lines first. 5 times 3, 15. -2 times 6 is going to be -12. 7 times 12, 84. Okay, so I will add this together. Right, I'm going to add everything together. And I will minus off all the red color things. So the red color one is 12 times -2, -24. This times this, so this will be 21. This times this will be 30. So I'm going to minus off all these red color things. And I will keep the modular sign over here. Okay, so how? So what is, okay, using your calculator, what is the number here? Calculator, 15. So what is this? The number very big so don't use brain, use calculator. So how much? 60. Wow, very nice. Okay, so half times 60. Now this one over here, right, means that it is a modular 60. Okay? So the area in the end will be 30 units square, like that. Okay? So what does this mean? Okay, so what does this mean? So maybe let me add one remark over here. Let me add one short note over here. Okay, so this one is actually what we call the modulus sign. Okay, this is what we call the modular sign. And means, especially for physics students, we are looking at the absolute value of this thing. Okay, means we are looking for the absolute value. Okay, now why are we using this? Because, okay, example, let's say a modulus of 60 is just equals to 60. But what about the modulus of -60? Let's say if you're careless and you get a negative number over here, the modulus of -60 is also 60. We are looking at the raw number only. Okay, now why? Because area is a positive quantity. We cannot have negative area. So let's say if we have to happen to calculate a negative area, we need to make it positive. So this is why the practice is to use this sign over here. Okay, so remark, so this is a modulus sign. Okay, Any questions so far? Don't have? Easy, huh? Okay, let's take a look at the next example over here. This one. Oh, do you want me to move to something, maybe this one? Shall we do this? Okay. Okay, so question 2A. Let's look at something with 4 sides now. And actually this one very exciting. Okay, especially when you got 0. Very exciting already. Okay, so question, yeah. The other method is you find distance and angle, you calculate yourself, which is me. Okay, alright, so question 2A. Okay, so over here, how do we find the area? Let us build our shoelace. Okay, now the key of building a very efficient shoelace is because we have a repeated point over here. If possible, we try to start and end with a 0. Okay, for example, which point do you want to choose that has a 0 over there? A or D? Okay, A or D. So which one you want, A or D? A. Okay, let's choose A first. So that point A, 3, 0. Okay, the next point, which direction do we need to go? Anti-clockwise. So 5 and 6. So 3, 0, 5, 6. Next one is 1, 8. Then the next one is 0, 2. Do we end off over here? No, we need to go back. Go back to the original point, 3, 0. Okay, now let's tie our shoelace. Blue color downwards, we add. Red color upwards, we minus. Okay, so how are we going to do this? So this is equals to half times, okay, so 3 times 6, 18. 5 times 8, 40. 1 times 2, 0 times 0, 0. Very nice. Next one, for the red color one, very nice. You got a 0 over there. So you have 0 times 5 is 0, 6 times 1, 8 times 0, 2 times 3. Okay? So blue color minus red color. Okay? So with this one, how? This is 48, correct? So this one will be equals to 24 units square. Okay, now then this comes to the next point. Why are we doing anti-clockwise? What if we do clockwise? Alright, so if you can try, you can rearrange this in clockwise manner. Okay, but what you're going to get is you're going to get a negative value over here. Okay, so one more time. If you are doing clockwise, you'll be getting a negative 48 over here. So modulus of this negative 48 will give you this one. Okay? So it will make a negative number become a positive number. So if you do clockwise, the opposite direction, your sign is going to be opposite as well. Okay? So technically speaking, clockwise, anti-clockwise shouldn't matter as long as you readjust back to positive number. But the good practice is anti-clockwise. A lot of things in maths, we go against the flow, we go anti-clockwise. Okay? So this is number 2. Let's look at one more crazy example. Oh, sorry, 2 more crazy example. Okay, 4 and 5. Okay, so question 4. So the coordinates of the vertices of a pentagon is that list of things. Find the area of the pentagon. How? Okay, so what should we do if we cannot imagine? Because for this one, we need to really see to do the clockwise, correct? So what should we do? We need to visualize. So on your own, you will need to roughly draw a soft Cartesian plane. Okay, so where is 0, 4? 0, 4 is over here. So 0, 4. Where is 4, 1? 4, 1 is over here. 4, 1. Where is 1 and negative 2? So 1, negative 2. Okay? Where is negative 4 and 4? Negative 4 and negative 4 over here. Okay, the last one, negative 4 and 2. Wow, here. Yeah, okay. So it's going to look something like this. Something like that. Something like that. Something like that. Not to scale. Okay. Yes, a very irregular one. Okay, so the nice thing is if you can fit everything into the Cartesian plane, your shoelace will do all the working for you. Okay, alright, so how can we find the area of this thingy now? Okay, so the first thing is to visualize. Okay, then the second one, calculate. Okay, so how do we calculate the area? Which point do you want to choose? Preferably the one with a lot of zeros. So which one should we start with? Let's start with this one, the 0, 4. Okay, so we start with 0, 4. Anti-clockwise, the next point will be this one, negative 4 and 2. Anti-clockwise order, over here, negative 4 and negative 4. Next point, 1 and negative 2. The next order, 4 and 1. Then we end off with the original point. Okay, so come, let us do this mechanical work. Okay, so blue, add all the blues, subtract all the reds. Okay, so 0 times 2, 0. Negative, negative will be positive 16. This is positive 8 plus 1 plus 16. Okay, minus of the reds, so minus of negative 16, negative 8, negative 4, negative 8, and 0. Okay, so what is in the bracket? $77. So this is going to be equals to 77 divided by 2. 33, no, 48. 48.5. 38.5. My math. Okay? Okay, last example of the day. Okay, the lastest example of the day. Question 5. Okay, and after this, we are done with question 7. Okay, not done lah. We are ready for war with question 7, with chapter 7. Okay, alright, so question 5. We have a quadrilateral PQRS with vertices, that one. So find the area of PQRS in terms of t, where t is more than 0. Okay, so let's do some visualizing first. Okay, because if you don't know, it will be very hard to visualize. So let's do some visualizing work. Okay, 0, negative 4 over here. Okay, 0 and 8 somewhere over there. Negative 5 and 2. Okay, over here. Okay, and if you observe, the coordinates of P is this one. And they say that T is more than 0 in the question over there. Okay, so where is the point? Which side will be this point? Top right, correct? It's going to be a positive number. It's going to be a positive number. So it's going to be over here. So let's say if I don't know, I just put somewhere over here. Okay? And it's not at 0, so it won't be on the axis. Okay? Now, so how? Yeah? Alamak. Okay, can. Let's swap the order then. Hiya. Okay, sorry. That means 0 and 8 need to be in front. Hiya. Okay, means I need to do the whole thing again. Okay, sorry. Okay, if we start from here. Okay, sorry. Incredibly sorry, but okay, the nice part is you get a lot of zeros again. Okay. Wow. So you see, very easy to get careless. But good that you point out. Okay, so over here, okay, 0, 20, 0, 16t. Okay, the next one is negative 40, 0, minus 8t, 0. Okay, apologies for this long thing. Okay. Okay, so what are we going to have here is half times of, okay, so we have, on top we got 20 plus 16t. Below, when we expand, careful of the signs. Okay, be very careful of the sign, yeah. Okay, so lastly we have half times 20 plus 40 is 60. This one is going to be 24t. So half of this, because t is a positive number, we can just remove this one over here. So this will be 30 plus 12t units square. Okay, so this is all that we have for area. Okay? Okay, now, so the lesson of the day is, today we did a speed run of chapter 7 concepts. The examples in the textbook are extremely long, so this is why I'm jumping straight to the textbook exercises behind to show you the raw concept itself. Okay, so the lesson of the day is, we are going to face very, very long questions and long and extended questions. But now we have a lot of power cards in our hands. At each situation, we just need to use different power cards and to use different tools to help us to find information or solve problem. Okay? So when we come back in term 3, we'll be doing a lot of that. Recalling a lot of concept and doing questions and throwing cards at the same time. Okay? Can? Okay.